Have you ever had a near-death experience? It's a moment that can change your life forever. Maybe you were in a car accident, a sudden jarring event that left you shaken. Or perhaps you had a close call with a serious illness, a battle that tested your strength and willpower. These events can be terrifying, leaving us with a profound sense of vulnerability. They make us face our own mortality, forcing us to confront the fragility of life. But what if there was a way to cheat death? A way to outsmart the inevitable? Not in a supernatural religious way, but through the lens of science. What if there was a scientific explanation grounded in the principles of physics? That's the tantalizing possibility offered by the theory of quantum immortality, a concept that stretches the boundaries of our understanding. This theory suggests that death might not be the end, but rather a transition. At least, not in the way we think of it, challenging our conventional beliefs. It delves into the strange and counterintuitive world of quantum mechanics, where the rules are unlike anything we experience in daily life. This area of physics governs the behavior of the universe at the smallest scales, revealing a hidden layer of reality. It's a world where things can exist in multiple states at once, a concept famously illustrated by Schrödinger's cat, where the act of observing something can change its reality, altering the outcome in unpredictable ways. It's a world that challenges our everyday understanding of how things work, making us question what we know. Quantum immortality uses these strange rules to suggest a mind-boggling possibility, one that defies logic. It proposes that whenever we face a life or death situation, we don't actually die, but rather continue in a different reality. Instead, our consciousness shifts to a parallel universe where we survived, creating a new path. This might sound like science fiction, but it's rooted in legitimate scientific theories, offering a new perspective on life and death. To understand how this could even be possible, we need to dive into the heart of quantum mechanics, exploring its deepest mysteries. The quantum realm is a place where the familiar rules of physics break down, and things start to behave in ways that defy our everyday experiences. Here, particles like electrons and photons don't behave like tiny billiard balls that follow predictable paths. Instead, they act like waves spread out over space, creating patterns that are more like ripples on a pond. These waves represent the probability of finding the particle at a particular location, rather than a definite position. Before we measure its position, the particle exists in a blurry cloud of possibilities, a superposition of all potential states. This is where things get really weird and counterintuitive. The act of measuring a particle's position forces it to choose one state out of many, collapsing the wave of possibilities. This phenomenon is known as wave function collapse, a cornerstone of quantum mechanics. But what happens to the other possibilities? Do they simply vanish into thin air? This is where different interpretations of quantum mechanics diverge, leading to various schools of thought. And it's at the heart of the quantum immortality debate, a topic that fascinates and perplexes scientists. Two of the most prominent interpretations are the Copenhagen interpretation and the many worlds interpretation, each with its own implications. The Copenhagen interpretation, the more traditional view, suggests that the other possibilities simply disappear upon measurement. It's as if they never existed, erased from reality. The many worlds interpretation, on the other hand, offers a more radical explanation, proposing that all possibilities continue to exist in parallel universes. The many worlds interpretation, or MWI, proposes that all possibilities are realized. Each possibility branches off into a separate parallel universe. So in the case of our near-death experience, there would be one universe where we die and another where we live. Our consciousness, according to the MWI, would then continue in the universe where we survived. This might seem like a mind-bending concept, and it is, but it's a serious contender in the world of quantum physics. The MWI elegantly addresses some of the perplexing aspects of quantum mechanics. It eliminates the need for wave function collapse, which has always been a controversial concept. However, the MWI is not without its critics. One of the main criticisms is that it's incredibly difficult, if not impossible, to test. After all, how do you prove the existence of a universe that you can't observe or interact with? Despite these criticisms, the MWI remains a compelling and thought-provoking interpretation of quantum mechanics. It's this interpretation that forms the foundation of quantum immortality. The concept of quantum immortality can be traced back to physicist Hugh Everett III. In the 1950s, Everett proposed the many worlds interpretation as part of his doctoral dissertation. His ideas were initially met with skepticism and even ridicule. Over time, however, the MUI has gained more acceptance within the scientific community. Another prominent proponent of quantum immortality is physicist Max Tegmark. Tegmark argues that the universe is far stranger and more complex than we can imagine. He believes that the mathematical structures we use to describe the universe are not just abstract concepts but represent actual physical realities. In this view, all mathematically possible universes, including those where we live forever, exist. Tegmark's ideas push the boundaries of what we consider possible. He challenges us to rethink our place in the cosmos. His work, along with Everett's, has helped to bring the concept of quantum immortality from the fringes of science fiction into the realm of serious scientific discussion. Section 5. Schrödinger's cat, alive, dead, or both. To understand the implications of quantum immortality, it's helpful to consider a famous thought experiment, Schrödinger's cat. This experiment, devised by physicist Erwin Schrödinger, highlights the strangeness of quantum superposition. Imagine a cat sealed inside a box with a device that has a 50% chance of releasing a lethal poison. Until we open the box, we don't know if the cat is alive or dead. The cat's fate remains a mystery. According to quantum mechanics, the cat exists in a superposition of states, both alive and dead, until we make an observation. This duality is at the heart of quantum theory. Now, let's apply the many worlds interpretation to this scenario. This interpretation suggests that all possible outcomes of quantum measurements are realized in some world or universe. When we open the box, the universe splits into two. Each universe represents a different outcome. In one universe, the cat is alive, continuing its life as if nothing happened. In the other, it's dead, having succumbed to the poison. Our consciousness, according to the MWI, would then follow the branch where the cat survived. This means we would only experience the reality where the cat is alive. This thought experiment, while bizarre, illustrates how the MWI could lead to quantum immortality. It suggests that in a life or death situation, our consciousness might always find a way to survive. Just like the cat, we could be considered to be in a superposition of states when facing a life or death situation. Our fate is uncertain until the moment of observation, and our consciousness would continue in the universe where we survived. This idea challenges our understanding of life, death, and reality itself. Section 6. Quantum suicide, a thought experiment. Too far? Taking this a step further, we arrive at the unsettling concept of quantum suicide. This thought experiment, a variation of Schrödinger's cat, imagines a person pointing a gun at their head, with each pull of the trigger having a 50-50 chance of firing a bullet. According to the MWI, there will always be a universe where the gun doesn't fire. Therefore, the person's consciousness would continue to exist, experiencing a seemingly endless string of near-death experiences. This thought experiment is highly controversial and raises serious ethical concerns. It's important to note that it's purely hypothetical and not something that can be tested ethically or practically. However, it highlights the extreme and unsettling conclusions that can arise when applying the MWI to the concept of death. Section 7. The many assumptions of quantum immortality. It's crucial to understand that quantum immortality is built on a tower of assumptions. First and foremost, it relies on the many worlds interpretation, being the correct interpretation of quantum mechanics. This is still a matter of debate within the physics community. Secondly, it assumes that consciousness is somehow tied to the quantum realm and can be transferred between universes. This is a huge leap, as we still don't fully understand what consciousness is or how it arises. Thirdly, it assumes that the branching of universes always favors our survival. There's no guarantee that this would be the case. It's possible that in some universes we might experience something far worse than death. Section 8. Against all odds. Arguments against the theory. Many arguments oppose the theory of quantum immortality. One of the strongest arguments is the sheer lack of evidence. While the MWI is a valid interpretation of quantum mechanics, there's no experimental proof that it's correct. Critics also point out that the theory relies on a misunderstanding of probability. Just because there's a non-zero probability of something happening, doesn't mean it's guaranteed to happen. Even if there's a universe where we live forever, it doesn't mean our consciousness will end up there. Furthermore, some argue that the theory is untestable and therefore unscientific. If we can't design an experiment to prove or disprove it, then it remains in the realm of speculation. Section 9. Can we really live forever? So can we really live forever thanks to quantum immortality? The short answer is, we don't know. The theory is intriguing and thought-provoking, but it's important to remember that it's highly speculative. It's built on a foundation of untested assumptions and faces significant challenges. It's crucial to approach these ideas with a healthy dose of skepticism. The universe is full of mysteries, and our understanding of quantum mechanics is still evolving. What we think we know today might be overturned by new discoveries tomorrow. Section 10. A fascinating idea for now. While quantum immortality remains a fascinating idea, it's not something we can rely on. We shouldn't let it influence our decisions or how we live our lives. Death, as far as we can tell, is still an inevitable part of life. However, exploring these mind-bending concepts can enrich our understanding of the universe and our place within it. Even if quantum immortality proves to be nothing more than a tantalizing theory, it reminds us of the vastness of the unknown and the endless possibilities that lie within the quantum realm.